Hi, everybody. This is Jill Richmond. My article is called Facilitating Mathematical Practices Through Visual Representations. This article is from the March 2017 edition of Teaching Children Mathematics, and it was written by Aki Murata and Chana Stewart. Chana Stewart is the teacher mentioned in this article, and she teaches first grade in an urban school district where 22 of her students' primary language was not English. My grade level is third grade, and I believe this article applies to all primary grades. This article talks about how visual representation builds the foundation for their future learning in mathematics, and teachers must be purposeful and careful in planning and implementing it in their classroom. This article also discusses different visual representations as these first graders solve addition problems using place value. My targeted topic is number sense, and the Nebraska Standard 3.1.3 will apply to this article, where students will compute fluently and accurately using appropriate strategies and tools. The beginning of the article talks about a little background knowledge about place value and about how it can be a difficult concept not only for students but also for teachers to teach. Here it discusses the picture to the left, and how visual representations make the concept concrete and help students assign meanings before they have to learn the formal notation and work. On the next page, this page shows the first example of visual representations. Stewart gave her students an addition problem and placed a printed 10 frame on the board with different colored magnets to represent each number. So the addition problem was 7 bubbles and 8 bubbles and 3 bubbles. They quarterly counted the magnets as she placed them on the board. She gave the students time to think about their answer, and then they did a pair share of their thinking with a partner. Then Stewart pulled the whole class together for a whole group discussion. The first student went to the board and moved the magnets around to show her thinking, while Stewart wrote the number sentence on the board to show the students' thinking. This student explained that she used a number line to solve the rest of the problem, and Stewart placed a number line below the 10 frames. Next, Stewart had another student who saw the problem differently come to the board. This was her example. And this student moved the magnets in the 10 frame to make a 10 first, and then counted the ones. This page explains another representation that Stewart used with her first graders. She gave them another addition problem here, and had a student share his thinking. The student explained that his strategy was decomposing the 10s and the 1s. And as he explained his thinking, Stewart used the making 10 strategy, drawing of numbers and lines on the board for the whole class to see, which is what this one is. Next, she guided her students' understanding by using the magnetic base 10 blocks on the board for the same problem, which are these. This table here shows all the visual representations Stewart used with her class in these two addition problem examples and how it supports their learning. So you can see she used the 10 frame with magnets, the number line, the base 10 representation, the making 10 drawing, and the base 10 magnets in only those two addition problems. The conclusion here discusses how the students, as they move on to work with larger numbers, they will be able to use the same representations to extend their understanding to the next level. Scroll. This page discussed how a classroom that uses representation allows for more students to participate and creates a culture of equity. The visual representations of their ideas also allowed students to see and understand their peers' thinking. I plan to use these visual representations in my classroom to deepen my students' foundation and learning. I use a lot of manipulatives while teaching math, but very rarely do the students actually see what their peers are thinking. They typically use the counters at their desk and do a pair share with a partner. When we do a whole group discussion, it's usually myself or a student drawing it on the board. We use the red and yellow counters in the base 10 blocks when learning place value, and some students use the system for addition and subtraction. I love the idea of using magnetic counters and putting them up on the board. This will be more visual to the students than just drawing pictures on the board. Whew, I might have made it right before the 5-minute cutoff. Thanks for listening to the explanation of my article.